Hi there. In this video, we'll be studying how to find the moment of inertia of a thin rod. Now, let us say this is a thin rod of mass m and length L. And we want to find the moment of inertia of this rod if it rotates about this axis. Let's call it OO prime. And moment of inertia is essentially nothing but m times r square for a point mass at a distance of r from an axis of rotation. So using this principle, let's take a small element here. And this element, let it be at a length of x, at a distance of x from this axis. And let the length of this element be dx. So now we can find out what is the mass of this element. So the mass of this element is going to be the mass density of this rod times, rather the linear mass density of this rod times the length of this element, which is dx. What is the linear mass density of this rod? That's the total mass of the rod divided by its entire length. That is the mass per unit length times dx. This will give us the dm for the point mass element. Now, the moment of inertia for this little element is going to be dm times x square. And this will work out as m upon L x squared dx. The net moment of inertia for this rod is nothing but the integral of all these moments of inertia for these elements. And the limits of this integral are going to be from minus L by 2 to L by 2. Minus L by 2 being this point, let's call it P, and L by 2 being this point Q. So let's integrate. So we have m upon L as a constant. We can take it out of the integral sign. And x squared dx from minus L by 2 to L by 2. And we know that this will work out to be x cubed by 3. And we incorporate the limits here. So we're going to get m upon L, L cubed by 3, rather L cubed by 3 times 8 minus L cubed by 3 times 8. And wrapping it in another bracket here. And this will give us m upon L times L cubed upon 3 and 2 upon 8. And this is ml squared upon 12. So with this, we have derived that the moment of inertia of a thin rod about an axis passing through the center is ml squared upon 12. We can use the parallel axis theorem to find out what is the moment of inertia about P or Q. And I'll reserve that for the next video. And I hope to see you coming back to my videos to check out concepts, problems, and you can also take a paid test series or a paid video package on the Unnati Academy app. And if you have any doubts, you can please mention them in the comments and I'm sure to answer them. Thank you so much.